Okay, Bismillah. So just to recap what we have covered so far in chapter 4, mainly we are dealing with moment. So we have covered moment about a point where n equals to mt in the scalar calculation, and also m equal r cross l in the vector operation, right? Also, we have covered moment about an axis. Scalar equation is still the same, m equal to mt, but of course the axis force. So we have to have a perpendicular, the distance perpendicular to both axis and the course. For vector, what's the equation? Right? So let's say we have the axis here, the force is there, so R can be any R from the axis to the force. Now we will cover something new, still about moment but a different category, moment of a couple. Okay. In Malay, saan. Now, so here we will cover on the definition of couple and also how to calculate or compute the couple. Now, in terms of application, some of the application that I think can appreciate. One is, for example, if you want to turn the wheel, the location of your hand when you want to apply the force, you can feel that when you apply it at the outer end here, you need less force compared to when it's closer to the center, right? So, of course, by experience we know this, but how to measure and calculate and represent the calculation in statics, that's the thing. Similarly here, if you apply force in your steering wheel, and I think there's a question here. Of course, if you have power steering, then that's a different case, because power steering is already applying, for those who are in mechanical, for example, they learn about hydraulics and stuff, right? But without that, if it's purely mechanical, meaning the whatever that is needed to turn the wheel is from our hand, then the amount of force that we need to apply is a consideration, right? Would older vehicle without power steering have larger or smaller steering wheel? Larger. Or if you have like a big lorry, right? You know that have you seen the size of the right? Why can't the lorry have a small racing? Okay. So it relates to the amount of force that we need to apply to rotate. Right? Now, so what is the couple? What is a couple and how to calculate the moment? Right? So a couple is defined as two parallel forces with the same magnitude but opposite in direction, separated by a perpendicular distance. So several things there. First characteristic, there must be two forces, and then it must be parallel. It must be opposite with the same magnitude. Of course, when it is parallel, you will have a perpendicular distance there. Right? Both will be perpendicular, right? And if it's parallel, that must be the case. Right? So all of those characteristics must be there for it to be considered a couple. Right? If it's not parallel or not opposite, then it's not a couple. If the magnitude is not the same, it's also not a couple, right? So dia kena sekufu lah berlainan jenis. Now, and in terms of calculation, so we have the calculation here. So we have moment So in terms of scalar, it's still the same equation, m equal to f times d. So if we have a couple like that, so the distance is exactly that. And in terms of vector, we'll have moment equal to r cross f. The equation is exactly like moment about a point. Right, but if we have a couple, for example, we have force here and here. Right. Can you guess where is the r, the position vector? Because here is from the point to the force, here from the axis to the force, right? Here from where to where? From both force to force. Now, if I take, because r, if you say from force to force, it can be from this to that, and it can be the other way around, right? Yeah. If I take r is from the force to the left to force to the right in this case, f here should be, because this f in vector form is the opposite, right? It's not the same. Magnitude is the same, but in terms of vector it will be opposite. So f here will be which one? On the right or on the left? We put here. Which one? If I use this, on the right, what?
It's
Pointing to? Which one is pointing? This one? What is one? Yeah, if you can now this one is related to the right hand rule, right? In this case, from the point R and then F, right? So the cross is R and then F, you get that rotation, right? Similarly here, right? R and then F, you get the rotation. Here you can verify, right? Okay, if you just see the two forces going in that direction, right? Which sense of direction will it produce? Clockwise or counterclockwise? Clockwise. Clockwise, right? Yeah. So if you use R and then this F, will you get clockwise or counter? You get clockwise, right? If you take this one, you get clockwise or counterclockwise? If you use this R. Of course it doesn't make sense, but if you just use R and then F upwards, you get counterclockwise, right? Which is wrong, of course. So in this case, the relationship is this: if you have R from this force to the second force, then F should be this second force. If you use R is here, F should be this one. Right, so any of this will give you the same. Because if R is to the left here and then F is this one, then you also still get clockwise rotation, which is consistent with what you know it should be. And it can also be from any point to any point, right? Just like this one. Okay, do you understand so far? So, why is this even a subtopic? Right? Because we have a moment about a point, moment about an axis. So, why do you discuss about this? Because couple have some special characteristics. So, one is that, let's say we have this couple here. One is if you do summation of force, what do you get? Zero. Right? Any couple will always give you summation of force 0 because it's the same magnitude and opposite. Right? What about summation of moment? Of course, it will relate to the force and also the distance, right? And if you understand this formula is just like the rest. The bigger the distance, the bigger the moment it produces, right? So that's one characteristic of a couple, meaning that regardless of what the couple is, whatever the force, whatever the distance, summation of force will always be 0, and it will have some value of moment depending on some parameters. So in other words, couple ni memang tak ada hasil, tapi dia pening kalau lebih jauh kan lebih pening. So that's the characteristic. Now this have an implication on when the couple is acting on the body, right? So, since the moment of a couple depend only on the distance between the force, the moment of a couple is a free vector. It can be moved anywhere on the body and have the same external effect. How many of you understand? Tak quite know. Tak ada pengalaman. Okay. Now, let's consider this body here. Right, for example, this is, let's say this is 1 meter, 1 meter, 1 meter, right? Now, let's say before we know about couple, right? Let's say we have, let's say 10 Newton here, and then let's say this is 10 Newton also, right? So meaning we have two couple, two forces. This is not the couple because it's both on to the right, right? Now, if we have this is point O, for example, right? Of course, the summation of force will be 20, right? What about the net moment about O? What do we have? Here, how do you calculate? Let's say if we take clockwise as positive. How do you calculate? Basically, you have 10. If you have this one, 10 multiplied by 3, and then this one 10 multiplied by 2, you get 50 Newton meter clockwise, right? What about if I consider this point A? So summation of moment about point A, what do you get? If we take, let's say I take counterclockwise. Clockwise. If we take counterclockwise, what do you get? This one? Doesn't produce a moment. This one? 10 times 1 becomes 10 counterclockwise, right? Now, normally any forces, the effect is different towards different point. Meaning about this point, it will produce this amount of moment, this rotation. About this point, this amount of rotation, moment, this rotation, right? You can calculate elsewhere, right? For example, if this is point B, the summation of moment B is what? If you take clockwise as positive. This one is 10 times 2, and then 10 times 1 becomes 30 clockwise, right? Now, as you can see that at different point, why is this larger than this one? Because the force is further away, right? And this one is smallest, and also the rotation is also different, right? So even if we have the same force, about this point the rotation is different, about this point the rotation is different, right? So that's normal, the characteristic, right? And if we, that's one thing, one phenomenon. Another phenomenon is if we shift the force, meaning that this pair, we shift it downwards so that it is here. Right, that's it. So what happened to the moment about O? Basically you get, okay, 30 clockwise, right? Calculate 10 times 2 and 10 times 1 plus, right? So what happened? Why is it reduced from this one? Distance becomes closer, right? If you calculate about A, basically the 30 counterclockwise, right? Why is it bigger than that one? The distance becomes larger from that point, right? So this is normal phenomena where what if the force is shifted, meaning if the point I apply the force is changing, we have the phenomena changing. Of course, in all of this case, summation of F will always be 20, right? So the summation of F doesn't change because the two forces is the same, but the effect on term of rotation is different based on if you shift the force or about different point, right? Now comes in the couple. The couple, because of its characteristics, so let's consider this one. If we put it on this direction now, it becomes a couple, right? Because it's the same force, the same magnitude, opposite direction. Now, what will happen to summation of moment about point O? How do you calculate this one? If we take, let's say we take clockwise as positive. 10 times 3 minus 10 times 2. You get 10, is it? Clockwise. Right? What about summation moment about point A? if you take clockwise?
10 clockwise.
Basically you get 10 times 1 equal to 10 clockwise, right? Well, if you take summation of moment about point B, clockwise, 10 times 2 minus 10 times 1, that you get?
10 clockwise.
Do you notice something?
Same.
The effect is the same. Meaning about any point, the effect is always the same. What if we shift the couple like we did before, right? Then the couple becomes here, right? We just shift it down. So summation of moment about point O right now is actually if you calculate 10 times 2 minus 10 times, yeah? 10 clockwise, right? Yeah? If you calculate 10. So you'll notice that couple is expression in that way, right? The net effect doesn't change, and meaning where the couple is, and considering any point, the level of moment is the same, right? So couple ni tu, dia pergi mana-mana tak ada hasil, pening dia macam tu lah. So that's the characteristic of a couple, right? So even though, because normally if we have, this is another case. For example, before when we learn about some moment about the point, where we have multiple forces, right? And what we do here when we calculate, actually we calculate moment about the point, right? So, but knowing that the effect is the same about any point at all, then comes to this equation. Then because the value here is actually just depending on the force, 10 Newton, and the distance of 1 meter, right? So if you do this, it's actually 10 times 1 becomes 10 clockwise. So the effect is always 10 clockwise. So that's why might as well just calculate for the couple. Meaning the effect about any point is just that, and we don't need to meaning if you say, oh, what's the effect about this point or that point or that point? No, it's always couple century. Right? So you understand the concept? Alright. So that is where it is stated as a free vector. Because because any other force as we show just now, we cannot shift the position, because when we shift the effect is different. But couple we can shift it anywhere. Sama je. Yeah. Right, so moment due to couple can be added together using this symbol. So of course if you have multiple couple, summation of moment is just the summation of all the moment, just like what we calculated before, right? So that's just normal understanding. Right. So in terms of the concept, do you understand? Of course we'll go into the calculation, but make sure you can express or explain your understanding here, because as we mentioned before, there are also some question in the final where you have some concept question. What happened if blah blah blah. So if it's couple, then you should be able to explain this, the fact that it's like that. Alright, now we go to some examples. So in this case, we have a beam over there, and this question already gives you the statement: two couple act on the beam, which is geometry shows. Of course, if we're talking about exam, there are questions where it is stated like this: oh, there's two couple, then obviously you switch. Okay, there's one couple there and there's another couple there, right? But it's not. Sometimes the question do not even say anything. You yourself have to be able to see, wait, that's a couple and that's a couple, right? So if you understand. So those two type of question that is possible. Now, find the magnitude of F. You have to see here F and F. That so that the resultant couple moment is 1.5 km clockwise. Do you understand the question? Again, the magnitude. Find the magnitude of F so that the resultant couple moment is 1.5 km clockwise. How many of you do not understand? So about. So what is this actually? What is this 1.5 kilonewton meter? The moment. Yeah, summation of moment is 1.5 kilonewton meter clockwise, right? So if you understand that, so as long as you can calculate what is the summation of force of equal to, it will equal to that one, right? Now, we have two couple. So one is basically this pair here. We have F and F. We have the distance of 0.9 meter. And then we have another couple, this one and that one. 2 kilonewton, the distance of 0.3 meter. So what you do is just summation of moment, and then we can do the summation. And to make it easy, I normally in this case I just take clockwise as positive, because in the end it will be clockwise there. So in this case, if you take clockwise as positive, this will be positive or negative? Positive. Why? It's clockwise, right?
Yes.
So you have F times 0.9. Is that positive or negative? Negative. 2 kilonewton, 0.3 equal to 1.5, right? Make sure the unit is consistent, because this is kilonewton meter. This one is kilonewton meter, so it's consistent. Do check, because sometimes the question give in different unit, and the diagram, for example, if this is Newton, that's kilonewton, then you have to make some adjustment there. Of course, if you have established this one, then the calculation will be straightforward and calculate what is there. Right? It's just mathematics. Calculation there. Any question? So this is one type of question where it uses the understanding of summation of moment and couple, and then you not actually calculate the summation of moment, because that's the given, right? To calculate the force, and the calculation is reversed in that sense. But as long as you can express that, it's okay. Okay, understood? Now, if you look at the slide, you will see that the equation actually considered counterclockwise as positive, right? So that's why this is negative, this is positive, which is the reverse what we have. And if you use this one, then make sure this one must be have negative, meaning that 1.5, because the question says it's clockwise. When you consider counterclockwise, so it must be negative there, and the answer should be the same, right? Okay. Right. So that's scalar. That's just 2D and scalar. So let's try with 3D vector calculation here. So basically we have m equal to r plus f. Now what's the question? So we have the two forces, 450 Newton, and the two is actually perpendicular and opposite with the same magnitude, hence a couple. So a 450 Newton force couple acting on the pipe assembly. Find the couple moment in the Cartesian vector notation. So in the end, we want the moment in vector notation, which if you apply this one, is already in vector, right? So instead we get the answer. So first you should understand the question. What is the question one? Is more of basically it's couple moment, and we can determine that we have couple there with the equation of m equal r cross f. Okay, so r will be from what point to what point? A to B. Can I use RBA? Yes, also right, it's up to you which because it's from one force to another force, right? The effect is if you use REB, F will be which one? F A or FB? MB. This one, if you use RBA, MB. So anyone still do not understand this concept? Just to make sure. You understand why if you use this one, you have to use this F? If you use this one, you have to use this F? Yang main gagal, make sure you understand. Okay, so in this case, if you know this, then as long as you can express the vector, you can just plug into the matrix, right? So what is RAB? What's the vector? X component? 0.4. Right. Then? 0G, 0K. Right? If you calculate RBA, what do you get? Okay, by the way, anyone have a different answer? Okay ke tak ni? K salah? Oh, okay. Now, okay, it should be quite obvious, but for those who tend to make mistake or something, just get the coordinate and then you minus, you get that one, right? Because sometimes some students, I notice, even though it's simple, but they because they normally calculate everything with respect to origin, so they make mistake there, for example, right? If you have that tendency, then make sure just make the coordinate first, because coordinate is with respect to origin, and then you minus, then you get that one, right? So everyone should know themselves and know what precautions they should take. What about FB? How to express this in vector? What is x coordinate? X coordinate. X component? For this one. Apa geling tu? Zero I. That is. Tu ni. One I. Ingat ni. Betul. This chapter 2, right? Zero I. Semua saja je buat muka poyo ke? Takut kita saja. Okay, what about Y component? Z component? Minus, right? Okay, so this again, all of this is chapter 2. Chapter 2 kan? So make sure. Okay, just two things about this. One is the most important thing. You are able to get this correctly. If you still have then make sure you remember, because again and again, every chapter onwards from chapter 3, 4, 5 and onwards, normally as we mentioned, this will be the first step. If you mess up here, then whatever you learn in chapter 4, 5, 6, in terms of the exam, still your mark will be quite terrible, right? Because it's mistake all over. That's number one. Get this correctly. Number two, for the exam purpose, get this correctly in a minimum time. Like this should be 5 seconds, 10 seconds. Like it's just take several seconds, right? So if you take like that means that in the exam you don't have enough time to cover all the questions, right? I know some students, I don't care about the exam, I really ta'ala saja, tapi but might as well you get a good grade, right? What about RBA? It will be just the opposite, right? Yes. I, J, K. And then this one will be the opposite also, right? So 0, I. For Y you get minus 450 over 5 J, and then plus 450 over 5. Obviously, you don't need to do both. You just choose whichever you want. For example, if you say, okay, I use RAB cross FB, straight away you do K, and then this one 0.4, 0, this one Right, and then you solve, right? Okay, in this case, what do you get? I 0 minus 0 basically, minus J 0.4 times minus 270, right?
Minus 0.
And then plus K
0.4 times
0.4 times 260 minus 0, right? And then you get in terms of J and K. Can you imagine what's the answer? What it means? Of course, in terms of calculation, then whatever the answer, that should be fine. But do you understand, if I is 0 and you have some J and K value, what will be the rotation look like? Boleh bayang? Basically, that refers to your thumb, right? So basically, if you can imagine the force is slanting that way, so it's actually rotating about that plane, right? And then it doesn't have any X component, it's just slanting in Y and Z. So it's actually rotating like that on that plane, right? So that's the meaning of whatever you get there. Right. Of course, in the exam, normally that question doesn't come into picture, but for the purpose of engineering, especially those who will deal with this thing, it's good if you can imagine what is the meaning of the numbers. Right? Oh, okay, that makes sense. But and this one, you should be able to reflect. I think in the IPE, one of the things that you should be able to do is reflect. Right? Meaning, is it logical? IGR is logical because if you rotate like this, the rotation is on that plane, right? It rotate that way. Okay, it's logical. You can check whether if you get something terribly wrong. Alright. So, and there you go. If you get the answer, it should be the same as we have shown here. So, any questions so far? If you notice that in terms of calculation, this one is quite easy compared to this other two that we have calculated because it's quite short. We just concerned about the two force and the whatever between the two force, right? In this case, we have to first concern about the axis, etc. Right? So, kalau you dapat couple, kalau you dapat question on couple, and boleh syukur lah. Right, I think the example here is using the same RAB and then FB. You can try on your own if you try what happened with RBE, FA. It should be the same because you get negative here, positive here, it will be just the same. Let's get. Alright, concept quiz. Form 1 and Form 1. F1, bukan asal dia sama ni. F1 and F2 form a couple. Form a couple. The moment of couple is given by which one? Which one will be correct? Based on this diagram here. C, B, okay. Antara dulu. Now, for those who say C, how do you get that? Yeah, R1 have to pair with F2, is it?
Yes.
But what you do is you actually rotate the equation, right? Can you do that? For cross, it will be the different, right? If you A cross B and B cross A is different, right? You can try. It will be something else. Because it will be the opposite generally something, right? So this should be wrong because it's not a couple. It should be R cross F, right? So the answer will be B, is it? R1 F1 was the problem. Okay, if you use R1, it should be F2, right? And if you use R2, you use F1, right? Now, this actually tests a little bit also on the understanding of how you can visualize. Because, for example, this R, some student might ask, dia tak sentuh pun force? Because it doesn't touch the force. But you have to understand the force is you can extend the force as long as you want, right? It's still the direction is important. So that's the thing. If you use R1 should be F2, if you use R2 should be F1, right? Now, another concept question. If three couple act on a body, the overall result will be which one? Which one? D. This one. Net force equal to 0, is it?
Yeah.
Yes. Any couple net force equal to 0. The net moment is not necessarily equal to 0, right? It depends on whatever value that we have. Right, okay. So you understand the concept. Right. Now, until now we for 2D we only cover the example where we have, I think it's vertical and horizontal force, right? Just now. Now in this case we still have two couple. Okay, this is another thing. If the question did not even mention about couple, can you actually just by looking, oh, couple, can you detect that?
Yeah.
Of course now because you already know, right? But because if something is drawn like this, it's quite obvious. But if like this, if you draw something like this, right? Sometimes the couple does not. Dia macam seorang nak belakang dia tak perasan. Okay, so that's one thing you have to be able to detect. But here when it says there's two couple, then obviously you can tadi I don't bisik saya ada dua couple. So but the thing is, for example, if this is the couple, right? What will be the distance? Can you imagine the distance? It will be this one, right? Yes. The issue here is to get this one is difficult because it involves many trigonometry, right? What's the easier way? Yeah, basically what we'll do as usual, we'll resolve into x and y, right? So that it will be, for example, this will be something like this, and etc., right? If you do that, basically there will be 4 new pair. That meaning this one and this one will be a new couple, this one will be a new pair, right? But because it goes directly to each other, then it doesn't have any rotation. So in that case, if you should be able to resolve and then visualize that. For in this case, for this horizontal one, it will be something like this. This will be the couple, right? What will be the value of the cos? 15 cos 30. 15 cos 30. The distance? 2 meter, right? Of course, another one is something like this, right? This is 15 sine 30. 15 sine 30. Right? Just to show that we understand, we just draw that one. Of course, in terms of calculation, it just becomes 0. What about that two force there, another couple there? If you take the vertical one, it will be something like this. The value is
34.
30 over 5. 30 over 5. What is the distance?
4 and 2.
2, right? From here to here, right? And then it will be something like this. Alright. This is 30 over 5. 3 over 5. Right. So we need to find the resultant couple. It should be the resultant couple moment because what we actually calculate is moment. So what is the resultant couple moment? If we take, let me take clockwise as positive, because I can detect it's going to be clockwise, right? Because this is clockwise, this is clockwise. If you take clockwise, not problem, you just get a negative value and it's clockwise again. So what happened here? Of course it's positive because clockwise, then 15 cos 30, distance of 2, this is just 0, this one is clockwise again, 34 over 5 times 2 plus 0 again, right? So if you calculate, you get whatever value there. And in this case, it will be clockwise. Right. Any question? So it's quite, again, it's quite simple if you get a question on Of course, especially if you get a 2D. 2D is very, very simple straight away. If you get 3D, then it's longer bit. Which one? This one?
Yes.
Okay, if you want to put in calculation, right? It's f times d, right? So if you get f is 15 sine 30, what will be the distance? Yeah, 0. So that's why. Because the distance, there's no distance between the two, right? Similarly there. That's in terms of calculation. In terms of understanding, it doesn't produce any rotation. Right? If here is rotate, here is rotate, here that. Another question? Right? But the concept is the same. When if you all have multiple couple in 3D, also you just R cross F, R cross F, R cross F, R cross F, right? Just identify the couple, right? The only difference is will be F and then R, etc. So in terms of the calculation, actually there's a question here also, right? Similar to the question just now. What's the question? The post component form a couple? No, only the 24. 24 is which one? Oh, it's this one, is it? Why? Because this one doesn't have any distance, etc. Right? It doesn't produce any rotation. So if we proceed with the calculation, you'll get this value here. Again, like what I showed, I take clockwise as positive. If you take counterclockwise positive, obviously there's negative here and negative there, and then you get negative value, meaning clockwise. Okay. And make sure you get the unit correct also. Kilonewton meter, because it's kilonewton and meter. Any question? Alright, so it's rather straightforward and not that difficult, right? Okay, what is this? The time? Because in the last class we actually stopped here in the section 1. So just so that I can put the level. Alright, so any question? So we have covered 3 components of this chapter. I think in the next class we'll have just a little bit more on couple moments before we go into something else. There's 2 more things I think in this chapter. Make sure you understand and show some exercises. We have completed chapter 3 quiz. Because that you did earlier is chapter 3, right? So in the next week maybe we'll go for chapter 4. I don't know, more about a point maybe. Right. So big, okay? Other than that, how many days is it before your midterm? 2 weeks. Make sure you log your. What was the date again? 22, yeah? It's Monday, right? 22. Alright, so be prepared. There's only like. Okay, normally midterm will cover the whole chapter 1 until chapter 4. Yeah, so what we cover is still going to be, and the next few things will still also be covered in the midterm. So do not delay to trying to, especially like I said, if you still take too much time on the chapter 2, but make sure you polish on that. Other than that, I think that's it. Any question before we end the session? Alright, so we end the session here. Assalamualaikum warahmatullahi wabarakatuh.